All right, happy Thursday. One housekeeping note, I did add the lab safety training link here. So if you'd like to get access to the game lab with your ID card, with the badge in, you have to have completed the lab safety training because computer labs count as engineering labs and some engineering labs have dangerous chemicals. We don't have any in our lab, but you still have to learn about them. So it's not terrible. Yeah.
So I am part of the game dev club, so I already completed a form and sent it to my president. Do you want me to just send that same certificate to you?
If you send me the certificate, I can submit that with a request for access, and then you get access to the game lab. If you already have access, great, you don't need me. But if you don't have access, I need the cert. Yep. Yeah, so take the quiz. You can go through a PowerPoint, you click through. You can keep the PowerPoint open while you take the quiz, which I would strongly recommend, because please don't memorize any of this nonsense. Take the quiz, you get an emailed PDF cert. I need that PDF certificate that has your name on it when I turn in the request for access, and then you can badge into the game lab. It is Dr. Bruce Maxim's lab, not my lab. Please don't break anything, because if stuff starts getting broken, he's less inclined to let me let people in. So that's all. Just, be kind in there. Lots of cool stuff in there, which is fun. And it's a nice place to hang out in the ELB. With good chairs. They got good chairs, for sure. All right, so a couple things today. I gotta get home a little bit earlier. My wife is not feeling well at home. You don't need any of the details, but I gotta get home sooner rather than later. So we won't go all the way till 8:45. I'm sure everyone's disappointed here. So we'll get through some advanced topics. I want to talk about the PokerHand class. I'm not going to do all of it here, but I want to show you some of the things we can do with it and how it gets used, that eye-comparable interface. And then next week, we'll finish up the advanced topics. We kicked the due date for this out until much later, so that's fine. I mean, if you get it done early, then you actually get a break for spring recess and nothing done to do there. If you don't, that's okay. There's also the midterm. This is not designed to be long, right? Ideally, I could sit and watch you take it, but I don't want to do that because it's terribly dull. So if you wait until that, you'll have the midterm and the project to do. It's up to you, right? So I'll let you make those choices there. And then if you are working in groups, I think I got a couple of requests for shared repositories. I set a couple of those up. Let me know. You're also welcome to do it the old-fashioned way and not have a shared repository and share files however you want to. I wouldn't recommend that, but you can, right? It'll still get the job done. And then come back in March and we'll move on to new stuff that we don't have a book for. So blitz through 51 chapters of this book here. 1 through 14 was really quick because it's like, here's how you code stuff that you've already taken semesters of before. So the interesting stuff is like 15 to 51. It's still a lot of chapters, but that's, pretty quick, hopefully. Again, let me know what you think about the book. I like it. I like that it's cheap, and I think he does a nice job of it, keeping it up to date, because other textbooks, they'll update new editions every year, but not actually change anything, and that always irritates me. So I think I've got a little vendetta out against Pearson, because they're just awful, but that's okay. All right, so let me pull up Visual Studio here, and then make a new project. Let's do... Should we do a form? We should do a form. Forms are fun because we can do some of the cool new stuff and talk about the class here as well. So make sure I put it in the right folder though. So here will be, we'll just call this one Poker for starting. And then we go grab a copy of the book here. Where is it? Player's Guide. There it is. So lots of fun stuff in advanced things, which is pretty cool. So we're not going to get super deep on all of these. I want you to know that they exist. I'll give you a little example here. Lambdas, people love. People love using lambdas. You'll see a lot of this in C#. This is what you'll usually get when you ask the chatbot for stuff. It uses lambdas. So definitely worth spending some time on that one. Events and delegates are really cool. We'll go through a couple of the cool features hopefully tonight. If not, next week we can get into those. We'll talk a little bit about asynchronous programming. Not too much there. Again, asynchronous programming is rather difficult. There's a whole joke about it. Someone had a picture on a wall. Did I show you that before? It says you must be this tall to write async code. I always laugh at that one because I think it's funny. We'll spend a little bit of time on that next week for sure. We won't get to that tonight at all. So we'll probably spend some more time looking at events and delegates and lambda expressions tonight. And look at the PokerHand class, and then we'll save some of this later stuff for next week. And then compiling, that's just a fun piece. I'm not going to spend any time on that. You can read it if you want. It's really interesting. I'm glad people care about that sort of stuff. I don't care how the compiler works. I'm just glad it works. Right? But really smart people know how it works, they understand it, and they make it do really fancy things, and I love it, which is super cool. Apparently we have a whole class on compiler design or something like that. Sure, that's really neat. And then publishing, if you actually want to publish apps, a couple routes for that as well, which is a lot of fun. Microsoft wants everything to go through their store nowadays because they get a cut of, sure, I mean, it's fine, it's an easy thing. So we'll get there. All right, so let's start off here making a class, because that's what we do here, right? Everything is classes. And again, I like one class per file. You don't have to do that, but that's what I like to do. That's what we're going to do here. So I'm going to make a card class to start here. So the card class, right, really just has two things. It knows its face value, right? Is it an ace, a 2, a 3, a 4, a 5, all the way up through king, right? And then what suit is it? So you probably remember this idea of an enum from CIS 200. I think we covered it in 200. An enum is a nice way to put a name to something. So I've got there's a constrained set of possible values. An enum is a nice way to use those values without having like the integer 1 or the integer 2, the integer 3, these magic numbers, right? I can put a name to things. And then there's an added benefit with enums is that they actually are stored as numbers. We just don't have to do all that work ourselves. So it's faster for the system to store them. Because storing something like a string, if I wanted to store the string hearts for my suit, takes up 1, 2, 3. I can't even spell, like 6 characters, right? And each character is 2 bytes versus just one number, right? Saves a little bit of space here. So it automatically does a little bit of that optimization for us. So we can do that. That's fine. So we can write an enum here for face. So the different face values, right? We have 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and I'm going to put ace as the last value here. Technically, aces are high and low in most poker games. Forget that. It's always high. Life will be easier this way. Again, we're cutting some corners just because it saves time. If you can get this far, I'm sure you could figure out how to also make a count as high and low. But we don't need to bother. Now, if I just hover over these things, you actually see it assigned them numbers already. Right? Face.3 is a 1. Face.6 is a 4. Right? Face.8, right? It just starting at 0 up through wherever. We just assign them all values now. So ace should be 12, right? From 0 to 12 is 13 values. Right? There's 13 faces in a deck. Sure. And then I might have an enum for suit. So we've got spades, hearts, clubs, and diamonds. Okay? That's my card. Now, I might need to use these other places. They might just be an internal detail. We'll figure that out later when we get there. So to make a card then, I'm going to have a private, or really just an attribute probably, right? So public face, I don't know, and public suit with sets and gets, right? Gets and sets. I can't use the same get and set public. I can't type tonight. My goodness. My hands are cold from walking outside. Lowercase f maybe? Lowercase suit? It doesn't. I can't spell. All right. It's less accessible than the property. Okay, well, let's make the property public. Public. All right. Now can I do my uppercases? I think I can do uppercases, right? No, can't. Lower. That's fine. Lowercase will be okay. It's not. Doesn't really follow our convention, but that's okay. Now a constructor, right? How do I make a card? So public card, given a face and suit. Look at that, it's suggesting it for me, I love it. So I can make a card given a face and a suit. It's really all a card does. right? Not too bad here. Now, cards should be comparable though, because if I have a hand of cards, like when we did Yahtzee, it's really nice to be able to figure out if you have a straight, if they're in order. If I don't have the comparable interface implemented, I can't sort my cards very easily. There's ways around it, but it's not easy. So card, we probably want to implement the I-comparable interface. Anytime you want to sort, you need I-comparable. That's one of the things we do in C#. It doesn't need the less than operator like C++ does for sort and algorithm. And I only know that because we just did that in the CIS 200 class. I would not remember that otherwise, but we use I-comparable. So we can say, hey, this implements I-comparable given a card, right? And then it says, no, it doesn't. And you say, yes, it does. And then you get some code. Okay, now I have some code. It's weird that it wants a nullable card here, but sure, that's fine. So when we compare two cards to say, is this card less than, equal to, or greater than? In terms of poker, do we care what the suit is? Not really. No? So all we really care about then is the face value. So I'm going to return my face minus other.face. And it might be null here. That seems really obnoxious. But what can we do here? I don't want... You can use an expression bodied method. Ooh. Save some curly braces. There we go. Okay, we saved some curly braces. You're probably not comparing to a null card. I'm not super concerned here. It's just a green line. We should be okay. So now I can compare my face minus their face. If my face value is a 2, their face value is a 3, it'll be a negative number. Negative means I'm less than. 0 means we're equal to. A positive number means you're greater than. So just some quick arithmetic, and it works out. So now I've got face, right? Or comparable. So let's add another class now. So now we can do PokerHand. And this is the 5-card PokerHand, right? So 5-card PokerHand, it needs to have a list of cards, right? So we're going to have a... Now, making that public and accessible gets a little bit weird, right? If you give someone a list, they can go change your cards. For now, we're just going to go with it. So we can say, hey, I want a list of type card. We'll call it cards with get and set. This is not great, and we feel bad about it, but that's okay. Come on. Where's my good? There it is. Oh, the spacing was super weird. This feels bad. Okay, we can come and fix that later. Oh, I guess capital C cards. There we go. Is it warning me about that? No. Okay, so we got to do a constructor. Sure. So we make a PokerHand. I need some cards. So I can either give it a bunch of cards, or I can set cards to be an empty list, and then I can start adding cards one at a time. However you want to go about this is okay. I think just having a default constructor for now is probably fine. So we'll say cards equals new list of card. Now it exists. We created an instance of it. Okay, so we can later we'll figure out how we add cards here. We can always change that when we want to. So PokerHand has cards. That's about it for right now. Now, if we want to be able to compare poker hands, and this is the big piece of this here, and I'm going to do some of it, we're not going to do all of it here, this should be I-comparable, right, to a poker hand. I should be able to compare myself to another poker hand and say, am I less than, am I equal to, or am I greater than, right? So let's implement the interface. All right, so not throwing an exception, right? So now there's no like quick way of saying, hey, can I just subtract anything? Doesn't work like that, right? So something we need to do is figure out what our rank of our hand is essentially. So this actually works out really nice. We can have another enum here. We can say rank. Could be high card, could be pair, could be 2-pair, could be 3 of a kind, could be, oh my goodness, and I gotta go look at PokerHand ranks, because I don't actually remember. Royal flush is not a thing. Bunch of idiots. I hate when they do that.
Flush straight.
Yes, but it's a straight flush. Just because you have ace high, there's not such a thing as a royal flush. Anyway, so high card, 1-pair, 2-pair, 3 of a kind, straight and flush. Straight, flush. Full house, 4 of a kind. 4 of a kind, and then straight flush.
That's interesting.
What?
Usually when we play full house is worse than a straight or flush. but
No, it's better. You're doing it wrong.
I guess so. That's why it's so interesting, because I was basically doing it wrong.
Yeah.
I did code it that wrong.
Yeah, and we don't have 5 of a kinds because we're not dealing with jokers. So we're just going to ignore it. Because playing with jokers is a whole other level of obnoxious, especially trying to evaluate what kind of hand is what, because that card then could be any of the other 48 remaining cards, right? Technically be the same, I don't know, can you have 2 of the same? The whole thing gets weird with jokers. It just is a little more hassle than it's worth, and we're not going to bother, okay? All right, so we have a bunch of hand ranks then. So at some point, I'll need to figure out what my hand rank is. So maybe we have a public method for that. Public rank, get hand rank. I don't know how to do this yet. So for now, I'm just going to return high card. Rank.highcard. And then we'll fix this later, right? To do fix me. Get hand rank. Oh, I have to make the enum public here. There we go. Okay, now I have a public enum I can use. Okay, so to compare to, the easy way to do this, right? We can say, hey, if my get hand rank is less than the other dot get hand rank, get hand rank, or really it does not equal, right? If one of them is different, I have a clear winner right away, right? That was pretty quick. I can just return get hand rank minus other dot get hand rank right off the bat. So if I'm a high card and they're anything else, they're greater. I'm less than, right? If I'm further to the right, a higher number. So again, we're sort of abusing the fact that enums are integers, which is nice. This saves us a little bit of time here. So if I'm a straight and they're anything to the left of me, a lower number, I'm greater. My number minus their number will be a positive number. Right? So we can compare. That works out well. The hard part here now is the tie breaks. If we're the same rank, now what do we do? Because this gets a little tricky here. So for high card, we look at all 5 of our cards. So we look at our first highest card. If those match, then we look at the next highest card. If those match, we look at the next highest card. If those match, we look at the next highest card. If those match, we look at the next highest card. If those match, we're the same. Right? And we have to do them in that order. So being able to sort my hand of cards is really useful. Right? Because if I sort it, my last card should be my highest card, unless you sort descending. And you can do that too. You know, it's up to you, any way you want to sort. So because cards are comparable, we can sort them really quick. We can take our cards list and sort them. Now the other thing we might want to do, and again this is, if you don't have 5 cards, it's really hard to determine what hand you are. We're probably always going to have 5 cards, but right now making this a public variable, like gets and sets, means people can screw with my cards. So for now I can just, you know, it'll say to do, might not need, if we always have 5 cards. But for now we don't. So we can say if my cards dot size or length, no, count. There it is. Cards dot count does not equal 5. We can throw I don't know, some sort of invalid error exception. What exception do we want? Invalid. I don't know. Invalid state. So, something's got to be fun in here, right? Or what sort of error do we want? Invalid, how about an invalid argument? No, where's that? Invalid enum argument exception? That's an interesting one. Argument, an argument exception, sure. That's not really, it says it's exception to throw when one of the arguments provided to a method is not valid. That's probably fine. So wait, we can throw a new one of these suckers. Say, oh, hey, bad stuff happened, game over, right? Or my other dot cards dot count does not equal 5. Right? If either one of the 2 hands don't have 5 cards, I can't do it. Right? Game over. So this is just our quick little safety check. Again, probably shouldn't happen, especially if we're managing this a little bit better. But just for now, this will make me feel a little better here. So for tie breaking, right, you have to figure out different tie breaks, because they tie break differently. So for pairs, The pairs get evaluated. What is the rank of your pair? If those match, then you look at the other 3 cards in descending order. That gets kind of screwy, right? 2 pair, you look at the higher pair, and then you look at the lower pair, and then you look at the 5th card if you have to. For 3 of a kind, who has the better 3 of a kind? If they're the same 3 of a kind, we'll look at the 4th card and the 5th card. Or, maybe they're a higher card, that sort of thing. For straights, that one's easy. It's just the high card, right? Because they're in order already. So that one's pretty quick to look at. For flushes, it's the exact same as a high card. The only thing a flush is we all have the same suit. So some of these we can share the logic of. Some of them we don't have to. Like, some of them won't share the logic. Some of them do. Some of them share part of the logic. It's a little weird. For full house, you compare the 3 of a kind first. If those are the same, then you compare the pair. If those are the same, you're equal. Right? For 4 of a kind, right? Which 4 of a kind is higher? If not, then you check the 5th card. For straight flush, exact same way as a straight. Right? Which high card's higher? So a couple different methods of tie breaking here that we can do. Eventually we'll return a number, right? So for now I'm just going to return 0. I'll leave that as to do. Tie break, each rank is a little special. Is that it? Right? Some of them are the same, some are different. So just as we're doing that, and ask ChatGPT, it probably does a decent job at this sort of thing, right? Once we start talking about link, some of the things it does will make a little bit more sense. Now you can also ask it not to use link, which is nice too. So if we go ChatGPT, so given a, we have to like give it a bunch of details so it knows what we're doing, right? Otherwise it's going to look really weird, right? So a poker hand, so in C#, given a poker hand class with a list of card class that has enum values, I don't know, sure. It has enum values for some suit. How do you tie break for, we'll say, flush? We'll see if the chat understands what I mean. It might not. It might. This was really slow earlier today. I don't know why it was so slow. It was kind of sad. Yeah, but still thinking about it. All right, well, wait. What do you think? Is this a cool laptop bag? I'm going to replace my backpack and want a messenger bag. It's got like a fake dragon scale look on the top.
I feel like it goes well with your shoes.
Could these poor shoes I've worn out, beat up real bad here. But.
Does it come with the D&D map?
No, it does not, which was sad. But it has straps for my battle map, so I can bring that with me. I don't know. That one looked fun. Apparently, they don't have a lot of D&D themed messenger bags on Amazon, which is sad. I'm gonna have to go to like some specialty store. Hey, here we go. Okay, so we got something here. So, if you want, you can tell enums what values they are. We don't want to do any of that extra work, but they did. Sure, why not? This is probably more useful if you're like adding things up for blackjack, right? And you want to sum up the values of your cards, but then things get screwy with jacks, queens, and kings because they're all values of 10, but that's another story. Card as suit, sure. Poker hand list of cards, cool. Assume there's more functionality to determine. I love this. It knows what we're going for. Why is it? Is it because I have that open? Okay, that gives me a little more space. So to compare flush hands, sure, it could be its own helper function. Sorting, what is this here? Well, this is link. We'll look at this in a little bit here. So this lets you sort descending by the card value right off the bat. So we don't even have to use the built-in sort. Sure, and it makes a new variable for it. Excuse me, and it goes and checks them. Gets the values out. If the values are greater, then we must be higher, right? Starting with the first card, we started descending, right? Otherwise, we're less than. If we've checked all 5 and we haven't returned yet, it's got to be 0, right? And then, hey, shows me some usage here. How about, can you write that without link? See if it does it with a regular loop. The like order by descending card value thing's a little weird. We'll look at that in just a minute. Sort cards and descending. It still did it. That's not... Cards that sort X, Y, Y, value. Okay, sure. I think that's even worse, but that's okay. All right, how about, so we should probably sort them at some point in here, right? Maybe after we get the hand ranks. Cards.sort. Other.cards.sort. This will just work because we use our default comparer. The default comparer is iComparable. It's the compare to method. That's why we write that iComparable, which is nice. So we're comparable, cards are comparable. We write hold'em hand will be comparable. Like everything will be comparable all the way down, right? Okay. So now we got some cards. Right, so somehow we have to get cards into the list of cards here, probably from a deck class or something like that that we manage. Right? So we don't want any duplicates. Like no duplicates. That would cause some trouble here. But should we show them somewhere? So if you want card to be represented as a string, right? We can override the toString function. Public override string toString. There we go. So how do I represent card as a string? Well, we can do our little formatted string here. And there's actually a really fun thing you can do in C# to get the value of something, right? With an actually enums do it as well too. Let's try. So we want the face, right? Dot. Is it toString? I think the face will do it here. So face of suit. I think this gives us so that the toString is implied because it's in our interpolated string here. So it should give us the name of the enum here spelled out for us. Should work pretty nice. And then for hand, right, if we want this one to return a string here, we do a public override string toString. I want for every card, I want to add them in together, right? So this, comma this, comma this, comma this. So I'm going to have 5 cards listed here, right? And then maybe even add in the hand rank. The hand rank might be fun to show that as well. It's not really working yet, but we could. So we'll make a string for, I don't know, like the result. Starts off as nothing. And then for each card in cards, I love when it suggests stuff for me. So we're adding the card toString. Probably also want to add in a space here, right? So we got a little bit of room in between them here. And then we'll take our result plus equals my get hand rank. Right? So I should have a bunch of spaces in between all my cards and a hand rank somewhere in here, and then I can return the result. Now this is a little bit bad. Adding to strings over and over and over with plus equals is technically slow. Remember, strings are immutable. Every time you add to it, you throw the old one away and make a new one. So I've made 6 different strings in memory here, essentially as we went. It's a little bit naughty. There's better ways to do it. We don't really care right now. It's better if we care. Right? Tostringing our hands is probably the least of our worries right now, but we could later if we wanted. Right, so now in our form. So now let's make a button here. Let's take a button. Here's a button. Let's say, I don't know, new hand. Sure, why not? New hand. And we'll call this the new hand button. Okay. And then we need a label somewhere. Probably up here. We'll call this the hand label. And then probably take the text out. We don't need any text right now. So when I click new hand, I want to do something. Well, let's make a new poker hand. Okay, so poker hand equals a new poker hand. Sure. And then I need to give it a bunch of cards. So if you had a deck class, that'd be really nice. We don't right now. That's okay. We can figure that out after. But if I want to get all 52 cards, I can have a list of cards equals new list of cards. And now with enums, you can loop over enums. It's sort of a collection here. So I can say for face. Nope, that was not it. Face. Is it it might be card.face. Yeah, card.face. Face in card.face. Dot. Oh goodness. In card.face dot. It's like values of or something like that. I don't even remember. How do you get you loop over and enum.
Choose enum dot.
Yeah, yeah.
Or
Enum
like,
dot get values. Enum dot get values of card dot face. That sounds right. No.
can you just leave it there?
Card face is a type which is not valid given the type. It's a for each loop. Doesn't like that. Get values of what? What did the chatbot tell us? Type of. Okay. Type of. Card face. Sure. Oh, I already had curly braces. All right, so now I can get each face. Goodness, that's kind of verbose, but that's okay. And we're going to do it again now for all the ranks. So instead of face now, all the suits. Suit. Okay. For every face, I'm going to go through every suit. Should we do suits first? Maybe we want to do suits first. It doesn't really matter. It's okay. So we'll take cards and we're going to add a new card given the face and the suit. Right? Now I should have 52 cards and I'm done. Am I missing a curly brace? There we go. If I want to add 5 random cards here, I got a couple options. I could shuffle it, right? Cards dot, I think is it shuffle? There's something in here to shuffle, I thought. Maybe there's not. There's like a randomize somewhere in here, but it's probably easier to just not even bother with that. So we can say, we'll take my hand cards, right? And we're gonna add, and now we need to take cards, and we want to remove at a given index. So remove at a given index, well, we can do random numbers pretty easily, right? Random, was new random. So to remove at a given index, we can take random dot next, say from 0 up to, well, how many cards do I have? Cards dot count. Where is it? Upset now. Okay, let's see. Next. Cards is not null here. Can't convert from void to poker card. Oh, remove adds void. Ah, shoot. It doesn't give me the card there. Okay, so remove ad's the wrong one. Want kind of like take it out. Where's our? There's too many options here now. Let's see. We could get by index. Move. All right, sure. Okay, so we'll get the card first, I guess, and then we'll do that. So we'll have an int for random index. Feels like there should be a better way to do this, but that's fine. This one here. And then we'll add the cards at the random index. Random index. And then we'll remove that from the cards. Remove at the random index. Right. Take the card from there, pull it out of the deck. Sure, we'll probably get the job done. I'm going to do that 5 times. Int card is 0, card is less than 5, card plus plus. Probably something like that. We'll move that in here. Oops, lost my eye. Now I have 5 random cards in here. Right, and I can take my label. Is it my hand label? Hand label? Yep. Text equals hand toString. Right, we wrote the toString method. We overrode toString, which should just give us a bunch of cards, plus a rank. Now our ranks are always going to be nonsense, right? Because we're always just returning high card. Because we haven't done it yet, but that's okay. So it should tell us it's high card. And every time we click the button, we should get a new hand. And this is a kind of nice thing, like a deck class could manage all that for us, and we don't have to do this by scratch. Or maybe you just don't even have a deck class. That's okay too. 5 of spades, 8 of hearts, 4 of clubs, 8 of diamonds, 10 of diamonds, high card. 10 of clubs. So different cards, different cards, different cards, different cards. Maybe we want to sort at some point. Yeah, we could sort. So maybe when we call toString, should that sort? Cards.sort. How about that? Or maybe every time we add a card, we could sort. We got lots of options, but now we should get a ascending order, right? So 3s, 4s, queens, kings, aces. Hey, not a bad hand. 3 high cards, right? 3, 6, 8, 10, queen. Sure. That seems like it's working so far. Again, not great representation of our hand, but it'll do the trick. We don't have to use pictures if we don't want to. Pictures are nice and cute. Sure, we're going to start easy, right? If you want to add pictures and make it look nice, go for it. You can do fun stuff with pictures, but for now we don't need to. That makes sense with our hand and where we can go with it? That's fun? Sort of fun? Okay. All right, let's see, that is not what I wanted. Here's the player's guide. Okay, so bigger programs. Right, some other fun stuff about it. We don't need to worry about that. You can go back and read it. That one's okay. I should have just clicked the next button. More about methods. Fun stuff with methods we can do. I don't think we'll do much of this stuff. There's some methods you can have variable number of variables. Kind of crazy sounding. But you can have the method, if I don't want to have an override for 3 options or 4 options or 5 options or 6 options or 7 options, right? I want to do the exact same thing every time. We can have the method take params as a string array, and you can just hand it either A or ABC, as many strings as you want, and it all gets stuffed into an array for you automatically. Just a little time saver. That one's kind of fun. Let me zoom in a little bit here, sorry. I go, it's kind of tiny. If you like passing by references, you can pass stuff by reference. Now, the primitive types are passed by copy. Right? Our ints, our floats, our doubles, chars, those all get passed by copy. Objects are already references. So we don't need to pass those by reference, anything special. They already work like that. But if you want primitive types to be changeable, you can pass the reference to your primitive type if you want. And there's also a fun little silly thing we can do with the out keyword. So the out keyword is our way around saying a method can only return one thing. Right? You get one return statement, it returns one thing. The out keyword lets you set values and then return something. So we kind of work around that. It's a little messy sometimes, but you can use that to give back more than one value at once. Right? Just a little shortcut. So something like trying to set the x-intercepts of a quadratic formula, because sometimes there's 2 intercepts, sometimes there's 1 intercept, sometimes there's no intercepts. Things get a little funny. So depending on how you want to write your function, you can return a value of yes or no, true or false. There are intercepts, and you can output out the other variables. You got some fun things we can do there. Sorry, I was trying to speed through this a little bit here. I got to get back soon. You can essentially unpack values. So if you want to return 2 things, you can unpack with a deconstruct method. It takes multiple things, turns them into one. Not too big of a deal. The static extensions is really neat. So static extensions let you add functionality to a class. So that was really neat. And that's how all this link stuff works we're going to look at after this. So when I looked at cards, where was it? Like cards dot. A bunch of these things are not actually in the list class itself. So this is distinct by, it says extension, IEnumerable of card dot distinct by card, comma, T key, the key type. This is an extension method. Comes from a different place, not the list class itself. So you can write additional functions that look like they belong with a different class, just to make our life easier here. Kind of lets you break things out as we go. So the link library, we include link, gives us all these fun extensions to any of our collections, which is really cool. Uses this weird this keyword, which is a little funny here. let's go see if he's got a good example in here. So we've got, where is it here? It's more outs. I zoomed in too far now. Destructors, extension methods. So I can write an extension to alternating that every other character, we're going to make a capital character. I don't know why you'd want to do that, but you can. So we can steal his code, which is great. We'll borrow his code. I'll throw that in here just for fun. So with a to alternating, given some sort of string here, what that lets you do now is when you have a string, I can say result dot to, where'd it go? To alternating, should be able to do it on a string. To alternating, come on. No extension. We broke it. Hang on, how did he do that? Yeah, to alternating. I must not have it defined in the right, oh, it's not in the static class, my bad. Sorry, you have to have a static class. More fun keywords here. So it can't be in this class. We need to add one more class here. So this is string extensions. That I can put in here now. So we put that in here. So this is a static class. So remember the difference between static and non-static means there's just defined once. You never make instances of this class. So we're saying everything in this class will be a static method. Right? We're never going to have an instance of string extensions. They just exist. And because this is static and the function is static, and it accepts a string here, this string, it's going to return the result. We can work on it. So now I should be able to take my results to alternating. There it goes. I think, because it returns it, I think I want to say result equals. Because it's not changing the right. Strings are immutable. So I could call the function, but it's not going to change my original string unless I reassign it here. But now I should get a really ridiculous looking hand here where every other letter is capital. Oh, that looks terrible. That's real bad. Right? But that's a fun string extension. So not super useful for strings. We should say this is from Sharp Player's Guide. Should give him some credit. Not super useful here. But as we work with other types, if you want to add more functionality to things, we can start adding these static classes with static extensions. Just another tool in our toolkit. We had a bunch of these. What did we do with our data access layer? You didn't have to build it all at once. We added in different things. When we talk about databases, it might be a little more fun to look at some of those things where the extensions make more sense. You can add more features there. This stuff is not super interesting. All right, so I can do that one. I'm going to comment that out because that just looks awful. Is that okay? Looks real bad. Wow, there it goes, coloring. All right, I think that was it for that one here. All right, error handling. Oh, we didn't even get to exceptions yet. I forgot. We hadn't talked about exceptions. Did you do exceptions at all in 200? Maybe?
I don't remember it very well.
Okay, so this is one of those things that it's a very object-oriented approach to bad things happening. So usually, when you call some code, something happens, right? So like I added this in here with our compare to. I'm going to throw an exception. So if I try and compare here, what your initial approach probably feels like is you want to, before we had exceptions, you probably wanted to say like console.writeLine, bad thing, right? That's about the only thing we had previously. We could spit out an error message somewhere, right? The problem with this is it doesn't, if someone's not looking at the console, it doesn't do anything, and then the code will still run and bad stuff will happen, right? This is not a good thing to do. So when we write classes that are self-contained, right, we encapsulate all of our details together here, if a bad thing is happening, the person who called the code has to do something about it. We can force them to do it with an exception, right? Because either the program crashes or they deal with it. And I don't know about you, but there's not very many things that are more irritating than a program crashing. It's really frustrating for some reason, which is sad. Like I should probably have a little bit more patience, but it's so easy to not have your program crash nowadays. It just frustrates me. So writing line is a bad thing. Maybe we could return 0, or I don't that's the bad too. Stops this all from happening, but then we don't get a good comparison. So the only real way to make the calling code do something about it is to throw an exception. Because they now either have to handle the exception or crash. Which is good, right? We want that to happen, because if something exceptional is happening, a bad thing is happening, there's nothing I can do to fix it inside the PokerHand class. If I don't have 5 cards, that's it. I just can't do this thing. Right? So when we think about classes maintaining their integrity, making sure they only do what they're supposed to do, and values stay within valid ranges, those sorts of things, we can use exceptions. So other silly things, that's not even a very good, when we had our shapes, when we did all the inheritance stuff, if you tried to set the length of something to less than 0, we just said, oh, I'll just stick it to 0. That's not really great, because someone might not pay attention or notice that we put it to 0. Right? If I really wanted to do something with it, we could force them to handle it by adding the exception. Let me go open that project, because that one was fun, right? Close this one here. We'll come back to it. It was our inheritance, right? Where did that? Object-oriented fun? Is that one where we did that? Yeah, we had rectangle, polygon, really any side length here. We didn't do any sanity checking on length here. You could have given me negative values, and my polygon would say, sure, that's fine, I can have negative values. It's just not really good if our logic depends on this, right? So we can check it. We can say, hey, if the side length is less than 0, because 0 might be valid, I guess. You could be a 2-dimensional object in the pretend world. I don't know. That's okay. We're going to throw a new is it argument as a value, invalid argument, argument exception. Argument exception says, oh, where did it go? I thought it was telling me about these here. Exception is thrown when one of the arguments provided to a method is not valid. There's a whole library of exceptions. You can use specific types. If you want, you can make your own custom exceptions, which are even more fun. It's just inheritance. You can inherit from an exception and be a custom version of it, and then now you have a new error type, new exception type. All sorts of fun there. But our purpose is, I like using the ones that are in the library already, because it's less work for me. And then we could give it a message. Hey, invalid length cannot be less than 0. I don't know, anything you want. You can give it any sort of message here, and this will pop up. So in our program, where we're actually making, nope, sorry, that was in our form, right? We were making some of these things. I wanted the code. So when I make some of these shapes here, if I were to set the side length to say -4 here. Oh goodness, little error. I missed my semicolon. There we go. So when I make a trapezoid, now I got, hey, there's an exception happening. Invalid length cannot be less than 0. And I can see, hey, it happened from my set side length here, which happened from my click object here. And I can go through my stack trace here and do something about it, or just crash. Right? Well, if I don't want to crash, right? So I think this is probably not a good one here. Let's put it in where we do our, didn't we get the values out of something? Didn't we have a form? What did our form have? Yeah, the length and width. Weren't we using those somewhere? We added a rectangle. Yeah, parse here. So if these were invalid, bad stuff would happen. So if I don't want my program to crash when I give it bad values, I'm going to use a try block. So if you're going to try something that might crash, you say try. I'm going to try this thing that might crash, and if a bad thing happens, I say catch. So catch says, hey, if someone throws an exception, I have to catch it. It uses sports ball analogy here, right? You throw something and someone has to catch it. If you don't catch it, if you drop the ball, program crashes. Right? So because of the magic of polymorphism, you can catch just a generic exception. This is generally considered bad form because everything is an exception. Everything inherits through exception. So we're catching every single possible bad thing that could happen here, which maybe it's a good thing, maybe it's a bad thing. So I want some sort of label, I don't know, polygon label, text, and we'll set, hey, the ex.message. There's a message that's passed by the exception, and I'll take that message and do it. Right? And then I'm going to move my update polygon into the try block. So if an exception happens, code stops running and jumps right to the catch block. It says, I can't continue on. So the only time this ever runs is if this does not throw an exception, which is good. Right? So if things are working normally, keep going. If something bad happens, jump to the catch block, do this instead. So when I go make a rectangle, I could have, hey, let's do like -2 and 5. And I get invalid length, cannot be less than 0. That's the custom message I gave my argument exception, right? If you want more info, there's a stack trace you can give it here. The stack trace is the whole everything here. So if I say, hey, -2 and 5, I get just like what we had over here. Hey, something bad happened. Oh man, that's super long here, but there we go. At line 29, at line 23, at 13, at 61. Your users could care less about this, right? Their eyes are going to roll in the back of their head when they see this. This is really useful to give developers. If I give this to someone and say, hey, your program crashed, here's the message, here's the stack trace, you know what line number to go look at. And you know what called it and what called it and what called it. This is super helpful to have. So, you know, we talked a little bit, you can have different ways of logging. We talked about that yet? No, I didn't get, okay, we'll get to that. So this might be something you log somewhere for a developer to look at, not show the user, right? That sort of thing. Or like, and an error pops up, they're like, hey, send this message to your administrator. You can have a button like, hey, copy this to clipboard, send this to your administrator. You could have a button that says, hey, do you want to report the error to somebody? Somebody probably gets those error reports somewhere, I'd imagine, hopefully, right? When things crash. I know when Baldur's Gate crashes, like you want to send a report to the developers. I always click yes, because I assume they're watching. They've patched often enough. They're probably fixing some of those bugs. So this is the kind of thing that'd be included in that log message, the error report. You don't have to show the users, but we got all that detail here. So that's all captured in the exception, which is super cool. So probably just the message is good though, right? Now the cool thing, because we're catching exception, not just invalid argument, if I say 2 and 5, I get the input string 2 is not in correct format. Remember we talked briefly that this parse method will just crashes real hard? When I hover over parse, notice it's giving more info. We never really looked at all the stuff it gives me, but it says, hey, exceptions, argument null exception, format exception, overflow exception. 3 different kinds of exceptions could be generated by this parse method. So if you want, when you catch things, you can catch specific exceptions. So we can say, hey, I want to catch an argument null exception and do something different. Then you can also catch a different kind of exception here. So if it's not a null exception, maybe now we give them the whole stack trace. If it's argument null, we just give them the regular message. You got all sorts of different choices here. So if it's null, overflow or format. Sure, okay. Really thought it would give me null, but that's okay. So wasn't an argument null exception. Must have been something else. I think it was probably a format exception then. Sure. Okay. Oh, because we're always going to have text. It's just blank. That's what it was here. So let's catch the next one here. Let's catch a format exception. Format exception. This might work a little better here. There we go. So now we get input string blank, empty quote, was not in correct format. So this was the format exception. Because I always have a string value here. It was just blank. So it's never going to be null. We could pass it null if we tried hard enough. But now if I give it like 2 and 5, 2 is not the correct format, right? That's my format error. What about -2? Well, it's not a format exception, so I get the stack trace, right? So when you catch exceptions, you want to catch the most specific one first, and then more general, more general, more general, more general. You can just catch exception, which will catch everything if you want at the end here. But that way you have a little more finer tuned control over what happens where, right? You can do that if you want. That's one way of dealing with our exceptions. So this is super cool because now our classes can communicate and say, you tried to do a bad thing, I can't do that, and make you do something about it. So it really lets them just stop the code from running. So if you give it a bad value, nothing happens at all, rather than I just set the length to 0. Just, again, probably not the right solution, right? That was our easy workaround to say, oh, if it's negative, we'll just put it to 0, right? Probably not ideal. So we've got the choices here, we got the flexibility. So a lot of classes will throw exceptions. So now we looked at, do I still have that open? Oh, I don't have it open. Let me close this one down and go back to poker. When I look at PokerHand, right, because one of these will throw an exception, right, my compare to, I want the code here. So I haven't actually done the compare to yet, but I think we look at PokerHand, hand.compare to. Oh, it's not even telling, so it doesn't even have that it throws an exception in there yet. We're missing a little bit of that detail. That's okay. What does it want here? That's fine. We know it could throw an exception, because that's what we wrote in here. Bad stuff could happen. So if we want, we could have a try block and say, okay, let's try this. If it doesn't work, hey, we haven't dealt the right number of cards or something weird happened here. Does that make sense? All right, so let's see. I guess 7 o'clock. Should we take a break before we do more new stuff? All right, when we take 10, we'll come back. We'll talk about a couple other new things here. I want to get into link, and then we'll probably call it a night. Does that sound good? All right, awesome. Let's take 10.